Hello everyone. So today in this video I'm gonna be proving wait one sec. Let me just close my door. Alright, I'm back. So we need to prove that the limit as x approaches to 0 of sine of x all over x is equal to 1. So let's start off by making a circle, or like the unit circle I meant. So just draw the coordinate plane. This is the x, and this is the y. So we just draw the unit circle. So it's not exactly like that. I mean, it's just okay. Alright, so now what I'm going to do is we're going to call this angle x, alright? And now what this is, if you've known the unit circle, you know that the radius is 1, and this is a right triangle, so the hypotenuse of this is just 1. And now the two legs of this right triangle, the height of this is just sine of x. So sine of x. And then the base of this small right triangle is just cosine of x. Now right here, this line that is tangent to this circle, that is just the tangent of x. So we can just label this as tangent x. Alright, so we got the unit circle and we got these three functions that we're gonna use. So what I'm gonna do is I'm gonna take these regions, so the small triangle, the sector right here, and then the big triangle, and then I'm gonna put them all as the area all in a relation. So it's just gonna look like this. So the area of the small triangle, which is just this one, is less than or equal to the area of the sector is less than or equal to the area of the big triangle. So then we have this. Actually, I'm just gonna erase this. It just takes too much space. So we have this relation right here, and you can kind of make sense out of this as to why this would work. You're just pretty much adding regions right here. So this whole triangle will be bigger. The area of this would be bigger than this, and it's also bigger than that, the area, but they can all be equal to each other. So now let's just find the area of this small triangle. So it's going to be 1/2 base times height. The base is cosine of x, so it's just cosine of x times the height, which is sine of x, is less than or equal to the area of the sector. So the area of the sector is just the angle divided by 360 degrees times pi r squared. But in this case we have x. So what we're gonna do is you can write it as x over 2 pi times pi r squared. Now if we simplify this, we can just get rid of the pi's, and then we're just left with let me just fix this. We're just left with x over 2. So x over 2 times r squared is less than or equal to the area of this. So the height is tangent of x, and the base is 1. The base is just the radius of this. So right here, this is just 1. So it's just going to be 1/2 times 1 times tangent of x. Now, we know that the radius is 1, so we can just rewrite this as x over 2. So I'm just going to erase this because 1 times x over 2 is just x over 2. Now, I'm just going to rewrite it as cosine of x times sine of x all over 2 less than or equal to x over 2 less than or equal to tangent x all over 2. Now what I'm going to do is I'm going to multiply each of these by 2. So we're going to multiply this one by 2, multiply this one by 2, and then multiply this one by 2. So the 2's cancel in each of these, and we're left with cosine of x times sine of x is less than or equal to x, and it's also less than or equal to tangent x, because the 2's just cancel. Now what I'm going to do is we're going to get this cosine alone, and so to do that we're going to divide each of these by sine of x. So sine of x. We also have to do the same thing for each of them. So the sine of x just cancel. You're just left with cosine of x is less than or equal to x over sine of x, just less than or equal to. Now tangent of x, let me just simplify this. So tangent of x is just sine of x divided by cosine of x, and this whole thing is just divided by sine of x. So when you're dividing by a fraction, it's also multiplying by its reciprocal. So sine of x over cosine of x it's just this whole thing is just the same thing as sine of x over cosine of x times 1 over sine of x. And then the sine of x just cancels, so you're left with 1 over cosine of x, so we can just write 1 over cosine of x. So now what I'm gonna do is I'm gonna take the reciprocal of each of these. So when we take the reciprocal of each of these, the inequality flips, so it gets reversed. So it would be 1 over cosine of x is greater than or equal to sine of x over x is greater than or equal to cosine of x. So now what I'm going to do is I'm going to apply the limit to each of them. So we're going to write it as the limit as x approaches to 0 of 1 over cosine of x is greater than or equal to the limit as x approaches to 0 of sine of x over x is greater than or equal to the limit as x approaches to 0 of cosine of x. So we can evaluate this limit because it's not going to give us an undefined expression. We don't have to use any other limit trick. But so to evaluate this, we just plug in x as 0. So substitute x as 0, and cosine of 0 is 1. So 1 divided by 1 is just 1. Is greater than or equal to the limit as x approaches to 0 of sine x over x is greater than or equal to. Now we can do the same thing right here. Just substitute x as 0 and cosine of 0 is just 1. So now we have this inequality. And you can, if you think about this, you realize that this limit right here, it's pretty much just being sandwiched by these two values, and both of the values are the same. So intuitively, you can say that this limit would be equal to 1. And you can, if you want to, if you're like in an actual proof, you would have to use the squeeze theorem. So by the squeeze theorem, the limit as x approaches to 0 of sine of x over x, it would have to be equal to 1, because this limit is just being sandwiched by these two values, and both of the values are same. And the limit right here, these two limits, when you evaluate them, they approach the same number. So when this happens and you're in this inequality situation, you can just use the squeeze theorem to say that this limit right here, this function right here, is equal to 1. So yeah, that's basically it. If you enjoyed this video, be sure to like and subscribe, and let me know if you have any questions. Just let me know and I'll try to answer them as soon as possible. Alright, goodbye.